Okay. Well, I'm going to do, real quick, again, Trey Shanks, Freese and Nichols, to just give you a brief overview of why this matters, how it affects you, and then lead into the approaches to address water quality. So, first and foremost, you hear about roads. You know, in Texas, we've got a lot of roads, 650,000 lane miles, which leads the nation. So there's a lot of roadways, and that accounts for about a third of the impervious area. So a lot of runoff from the roads, and there's pollutants that come from the use of the roads. We've got 6.5 million people in the Metroplex, average, driving about 15,000 miles a year. That's billions of miles, driven each year just in North Texas alone. That results in a lot of potential pollution. You get wear on your car, there's oil or metal breakdown. You get the trash from whether it's the cars not paying attention to the don't mess with Texas, eat it, or maintenance on the road itself to make sure they're drivable. Salt, sand, or just trash, unfortunately. So a variety of things. It's also a conduit for runoff from properties. So for a lot of cities, the roadway system is part of your drainage system. So it's collecting from more than just the roadways itself. Here's the list. I'm not going to go through this obviously one by one, but there's a whole variety of pollutants that come from a wide variety of sources that need to be considered in protecting water quality. It's all of this aspect is about protecting water quality as it goes into your creeks and water bodies. For all those pollutants, here's a wide range you see of the pollutant levels. This is from EPA. You see a wide range of pollutant loading from the different sources. So TSS, total suspended solids, is really one of the common parameters to evaluate pollutant loadings. But you've got metals, you've got bacteria, oils, nutrients, all different types of pollutants that are an issue and of concern to protecting water quality. In North Texas in particular, our water is, we don't have salmon runs, and we don't have trout, unfortunately. But we drink this water. This goes to reservoirs that we drink from. So we have a vested interest in protecting that water quality. A variety of ways to take care of pollution from streets as a source. What we're going to talk about specifically today is design approaches for that. But there's activities during construction and maintenance activities as well that have a significant impact. So the approaches of protecting inlets, silt fence for construction activities, proper management practices, street sweeping from a maintenance standpoint, or having good spill prevention plans to, in the event of a release, to protect that spill from getting to the creeks. Just general good practices that are available for that. But in particular today, we'll focus on the design components. So, really not going to get into the details on regulations themselves because it's too close to after lunch when they fall asleep. But there are specific requirements out there. Okay? There's MS4, Municipal Separate Storm Sewer Systems. Most of you probably work for an entity that is an MS4. If you're in North Texas, you are likely working for an MS4. That takes care of the ongoing need and operation of your municipal storm system, and a significant component of that is how design occurs. Construction, general permit, you're familiar with that. For the silt fence, construction SWIPs, the stormwater pollution prevention plan, and then industrial stormwater permits, which hit certain industrial type facilities. And for cities in particular, it's landfills and airports, wastewater treatment plants, but it's all a lot of industrial facilities have to have that on an ongoing basis for their operations. So really since the mid-90s, these blue cities and entities have had to have an MS4 permit and a whole program in place to protect stormwater quality. Anything from public education and outreach to approaches to how development occurs in the city. This includes TxDOT and NTTA. This has been going on. These are phase 1 MS4s, the large entities throughout the Metroplex that have been dealing with this for nearly 20 years now. But over the last 6 or 7 years, it's now brought in the smaller entities in the Metroplex and really throughout the state and the nation. In Texas, in particular, North Texas, you see how this is pulled in the rest of the Metroplex. All the highlighted cities are subject to the MS4 program. And why does that matter? Because you have to minimize pollutants. You have to have a program to minimize pollutants. Some of you are within this bordered area, this red bordered area. You happen to be discharging to an area that already has impaired water, has degraded water quality, for bacteria in particular on this one. So there may be more specific requirements that are necessary for how you handle design or maintenance and operations of your roadway system. So different approaches to get there for this. Like I said, public education and outreach. Some, especially the larger cities, have monitoring requirements. Actually get out there and sample and identify what pollutants there are, what the levels are, and identify approaches to minimize those pollutants. For industrial facilities, the airport, for example, that ethylene glycol, minimizing that. Down the bottom right, you see really not the recommended use for an inlet. I'm not sure you can tell what this guy is doing, but he's stuffing a branch into the storm inlet because that's out of sight, out of mind, and it's taken care of. That's from last week. That's a real, not a stage picture from last week. But more specifically, for y'all, the components that we'll talk about, on the bottom left, you see post-construction. It really gets to designing a system so that it has a water quality protection component. You see a little curb cut out there on a roadway. Design that appropriately. During the construction, put in the proper features to protect from sediment runoff and other pollutant runoff. And then on the right, maintain it. Proper maintenance of your system to take care of it so it works as intended, the way you designed it. Back on the left again. So these small cities, large cities have these specific requirements. How this specifically affects you is there's the goal up top of minimizing the discharge of pollutants for new development and redevelopment. For any site that disturbs 1 acre or more, okay? Unless it's what's called a larger common plan of development. That's a collection of developments or activity that is considered to be one activity overall. Even if as parts they'd be less than an acre, collectively they'd be more than an acre, be subject to it. Must have a program for maintaining these best management practices over the long term. And as that last star shows, for the smaller cities, there's a specific permit requirement that this program must be maintained for not just public but also private development sites. On the construction side, a similar component. It's during construction activity, okay? From when you first disturb to when you have final stabilization, which means you've got your vegetative cover or you've got it paved. Same way that it affects 1 acre or more for the larger common plan development. You have to have a stormwater pollution prevention plan you're familiar with. Maintain that throughout the construction period. So back more than 10 years ago now, COG put together, began development, the ISO manual, and that was back in 2002. That was to have a regional program for stormwater management that, in anticipation of the small cities being pulled into these MS4 requirements, to account for flood protection, streamway protection, and now water quality protection. That initial ISO manual was completed in 2006, and hopefully you've all forgotten by now, but there used to be this onerous manual that is no longer. It's a beautiful, nice, tight, concise manual that was updated in 2009. It has a lot of reference material for your reading pleasure. And that's been broken out this way as of 2009 into what the specific criteria is, the TriSWM criteria manual itself. There's a technical manual as well, and then some supporting documentation on top of that. So really as far back as 2006, when ISWM was first completed, cities began incorporating and adopting the ISWM manual. So Fort Worth and Grand Prairie got off to the first start with it, and you see that cities have been continually bringing in its components ever since adopting ISWM up through as recently as Hearst this last year. You see that Fort Worth, Dallas, larger cities, you see some of the smaller cities as well. It's not really size specific as far as who is incorporating the ISWIM components. So the way ISWIM was developed, it's for all development, and there was a consideration that it might be beneficial to have a component specifically for linear systems. So COG developed TriSWM several years ago to apply the same ISWIM principles to roadway projects in particular, and we'll talk about that. It provides guidance for local governments of how to apply the ISWIM principles on your roadway projects. It has planning tools for you to evaluate in your projects. And Jeff's going to talk specifically about TriSWM.
Okay, thanks, Trey. Trey mentioned the ISWIM criteria manual. It is a relatively easy document to wrap your mind around, as opposed to the bigger ISWIM criteria, or the original 2006 ISWIM manual. And then the TriSWM component is an addition to the ISWIM criteria manual. And so, as Trey said, ISWIM is largely geared towards private development and parcel-based development. And in partnership with our transportation department, several years ago, we worked on developing the TriSWM guide. It was actually incorporated as Appendix J to the original 2006 manual. Since we've updated the ISWIM manuals, we realized that we needed to incorporate TriSWM into the new documents, and so we updated the information and worked through the same committees that we worked with originally in the original development of the TriSWM guide, which was our ISWIM implementation subcommittee and our Public Works Council, as well as interfacing with our transportation department, and then we had discussions, conversations with TxDOT and NTTA and others, primarily in the original project, but to a certain extent with our update as well. The update, we did revisit the information. We found that it was sound, and we did add some additional information based on some comments. But if you're familiar at all with the original document, the new one, other than the format, won't look that different. And so the TriSWM appendix is the official name of it. Transportation Integrated Stormwater Management Appendix is really an overlay to the ISWIM criteria manual, and it replaces or modifies certain sections or chapters of the ISWIM criteria manual when it's applied to streets and roadways. And it's intended to be adopted by local governments as they adopt the ISWIM criteria manual. It's certainly one of the many options that they can choose to adopt or not as they implement ISWIM. For the TxDOT and NTTA, we realize that you have specific policies, manuals that govern the way that TxDOT develops projects, and to the extent that TriSWM can serve as a resource, as guidance to your project where it doesn't interfere, then we hope that you'll use it as just that, as a resource. And then also that hopefully you'll be familiar with it. So when you're working in various cities that may have adopted the TriSWM appendix, then you'll be somewhat familiar with their utilization. So again, it's intended for linear projects and specifically for streets above, I guess, a residential classification, so collectors, arterials, and highways. And really the distinction is because, like I said, ISWM is based on the private development process. It's a document that a city can hand to a developer and say, here are the requirements that you need to follow as you develop your stormwater infrastructure plans and designs. Residential streets, are part of the drainage system for subdivisions. And given that you have kind of a clean slate when you're working with a plat, you have the ability, as well as the land available, to better plan for the types of stormwater controls that you would want to incorporate as you're planning the overall development. When you get into the public planning and development construction of linear systems, it's a little more difficult. You're constrained, by right-of-way and other factors, and so that's where we kind of make the distinction between where ISWM is applicable and where TriSWM is applicable. So most of the ISWM criteria manual, kind of as is applicable. The sections on hydrologic methods, the downstream assessment, stream bank protection, flood mitigation, the conveyance system design, construction criteria, and most stormwater controls are all good for use for linear projects. I say most stormwater controls because for the TriSWM application, we took out green roofs and cisterns, which really don't apply to streets. And then the technical manual really mirrors the ISWM criteria manual. So those same sections in the ISWM technical manual would also be applicable. So the differences, TriSWM replaces Chapter 1 and Chapter 2, which are really the introductory sections of the criteria manual. Chapter 1 is an overview, and Chapter 2 describes the private development process. And so TriSWM talks more about the local government project planning process, so starting with the identification of the needs in a thoroughfare plan or other document, comprehensive plan, incorporating it into your CIP and bond program, that sort of thing. So that's what's described in TriSWM, as well as the type of site analysis that you would want to conduct as you're doing the planning for the project. Your soils, your streams, location of any sensitive natural resources, topography, those common site and environmental factors. And then has some information on some special planning considerations that you might want to take into effect if you are going to potentially have impact on, say, floodplains or wetlands, if you're discharging to an impaired water body, if the roadway is designated as a hazardous cargo route, some of the additional types of considerations that you might want to look at. Also, TriSWM modifies the ISWM criteria manual is in Chapter 3, the integrated design criteria, and that's primarily on the water quality protection criteria. The integrated design criteria deals with water quality, stream bank protection, and flood control. And the stream bank protection and flood control sections are largely unaffected. It's the water quality protection that we kind of did some modifications to for TriSWM. Water quality, what we developed was coming up with a treatment criteria based on projected traffic volume, and environmental factors. So basically the quality of the receiving waters or any sensitive natural features that you have in the vicinity. I mentioned stream act protection and flood control. It looks at the downstream impacts and then has methodologies for how you might address and mitigate those downstream impacts from increased flows and volume. Same with flood control. So as I mentioned, the water quality criteria is really where TriSWM rather is quite a bit different than the TriSWM criteria manual. And through some research, we found that FHWA and others were publishing a lot of studies, some of them coming out of Austin with Michael Barrett at University of Texas at Austin, suggesting that, or demonstrating that the amount of, the levels of pollutants in runoff was significantly higher on roadways with traffic volume above 30,000 vehicles per day. And below 30,000 vehicles per day, you typically would see lower pollutant levels in the stormwater runoff. So the criteria matrix has the traffic volume on the y-axis there, the columns, and then the x-axis would be the receiving water and the susceptibility of the riparian areas where your project will be discharging. And so the combination of those two factors results in requirements of level 1, 2, or 3 treatment controls. And I'll discuss in just a minute which types of controls and practices are contained within each of those level 1, 2, and 3 criteria. And so for the receiving water and riparian area susceptibility, starting with high susceptibility, I guess if you will, if you're discharging to exceptional quality aquatic habitat as identified by TCEQ, or into endangered or protected species habitat as identified by Texas Parks and Wildlife, then that would be one way to be categorized as high in terms of those receiving water susceptibilities. Or if you're in close proximity to the drinking water supply and the drinking water provider has concerns about the impact of the project on water quality. So those are the high levels. For moderate, would be those sections, segments rather, that are designated with 3 or more uses on the Texas Surface Water Quality Standards, which is the set of standards, water quality standards document that TCEQ publishes, I think about every 4 years. The most current one is the 2014 Surface Water Quality Standards. That applies to the surface water quality in the state right now. EPA hasn't approved that, so for federal projects, I believe it's still the 2010 surface water quality standards that applies, but currently for state and state waters, it's the 2014. The surface water quality standards sets goals for the quality of all the major river segments, I guess, in the state, and reservoirs on those rivers, as well as coastal resources as well. But here we're just talking about streams and rivers. Supports public health, protects aquatic life, recreational use, aquatic life use, and domestic water supply. So for those segments that have 3 or more designations on the surface water quality standards, that would be a moderate resource. And then wetlands receiving more than 10% of the total flow from the project. So if your project is discharging a significant amount of stormwater runoff to a wetland that could be impacted. that would likely be, or that could be in the moderate category. I did mention for the surface water quality standards, those are really the major segments of rivers and reservoirs in the state. The moderate would also apply to any perennial stream that's not classified by the surface water quality standards. So that's going to be, a significant amount of the streams in the region. The final category, minimal, is all receiving waters not classified above, and really what that amounts to is intermittent streams. So if you're discharging to an intermittent stream, then it would be minimal. So in the Metroplex, we don't really have any exceptional quality aquatic habitat designated right now. I guess that could change in the future. We do, I believe, have endangered species habitat. So if you suspect that you have endangered species or habitat, you need to contact Texas Parks and Wildlife to determine that. But really, most of the receiving waters that you're going to be discharging into are going to fall into the moderate or minimal categories. And a fair number of those will probably be in the moderate category because of it being perennial stream. And you can see that for minimal quality, if you will, receiving waters, it's level 1 treatment. For moderate, for below 30,000 vehicles per day, traffic projections, it's level 1, and for over 30,000, it's level 2. In the high susceptibility column, for low traffic volume, it's level 2, and for high, it's level 3. So those treatment practices and controls that fall into those categories. For level 1, it can be just what probably a lot of you are doing already, which is a program of scheduled pollution prevention practices, so street sweeping and storm drain inlet cleaning. If you've got off-site practices like regional detention, that could be used for water quality purposes, then you can utilize that. It also encompasses grass channels, so basically a bardage, the picture on the top right there. The way the grass channels work, it allows the stormwater to flow over vegetated areas. Some of that, some of the pollutants will be filtered out, and some will infiltrate in that first flush, and thereby removing some of the pollutants. We won't go into a lot of detail about these different practices today. We've done other presentations that have more information on stormwater controls that are available on our ISWM website. But Leslie and Dorsey will be talking about applications of these controls in the projects that they describe later, in case studies and other material we have for you. Another level 1 treatment control is filter strips. That would be the bottom left picture shown in a commercial application, but it involves just sheet flow of stormwater runoff over a vegetated area before it would either be discharged directly into a receiving water or before it is collected and conveyed to an outfall into receiving water. Gravity separators, hydrodynamic separators, storm scepters, that sort of thing that remove post-suspended solids as well as trash and skim off the petroleum products that might be floating on the surface. And then porous concrete that could be used in alleys or on the parking section of the streets, and porous paver systems, I guess in certain highly urban areas for decorative treatment and for infiltration. So stepping up to level 2, and that would kick in again in the moderate susceptibility and greater than 30,000 vehicles per day. The controls that can be used there are enhanced wells, which would be the top right picture, which provides a underground engineered filter media, as well as an underdrain, unless you have highly infiltrated soils, which we typically don't have here. It's really a linear bioretention area, and some people refer to them as bioswales. So enhanced wells and bioretention are pretty similar. It's just what different people call them, and a lot of times whether it's for a parcel-based development or whether it's contained within the right-of-way. Here you can see it's used in a depressed median, so rather than routing the runoff straight into an inlet at the curb and straight into the receiving water, the water runs off over a filter strip, collects in a open channel, grass channel, and is treated and infiltrated further in the enhanced well or bioretention. Another more urban application of bioretention or bioswale is the bottom right picture, and we'll have many more of these. And then dry detention. If you have an adjacent park or right away within an interchange or something like that where you could do detention, that would be an option. For level 3, this is really only in the above 30,000 vehicles per day in the high susceptibility category, and the treatment practices sort of reflect that sensitivity. So sand filters, underground sand filters, which are used quite a bit in the Austin area. Those provide a pretty high level of treatment. Organic filter is like a sand filter, but uses an organic media to help further bind metals. And then infiltration trenches. Unfortunately, we don't have a lot of A and B soils here, so but where you can use them, they're a good control and can be utilized. Again, where you have more right-of-way, stormwater wet ponds, and stormwater wetlands. Those are not natural wetlands, but constructed wetlands that are used to treat stormwater runoff. Alum treatment systems, which provide for I guess flocculation, settling of metals. And then, as with the level 2, supplement with any of the level 1 or level 2 BMPs. So that's the list of the stormwater controls. Quickly, here's just some of the removal rates that that you can find with the different practices. The level 1s, you see the TSS removal rates are in the 40 to 50 range. For level 2, dry detention, it's 65% removal with TSS, 80 for enhanced well and bioretention. And then for level 3, TSS is 80% for all of those. Some of the practices are better than others at removing nutrients, which typically for right-of-way you wouldn't find too many nutrients other than if you're applying fertilizer. Fecal coliform, the dashes indicate, this information came from TriSWM, the ISWM manual, which was originally developed about 10 years or so ago now. There may be more information now, but what's in ISWM at least doesn't show a lot of, there wasn't data available to establish the removal rates for people coliforms, but some of the BMPs work better than others. We do have bacteria TMDL in the region, and infiltration is really the best removal practice for bacteria. There is some thought that stormwater ponds with sunlight breaking down the bacteria, or fire retention also has, really well, it's not shown there, but some benefit for bacteria. And then a variety or sort of a range of removal rates for metals. So kind of pulling back and looking at a little bit of the broader perspective. So that's the water quality piece, but you also have impacts from the increased amount of runoff. And so what ISWM and TriSWM have as part of the criteria is conducting a downstream assessment to look at the impact of the additional runoff on the stability of stream banks, as well as potential for increased flooding. So you would want to look at that. And then sort of at a higher level than that, if you're looking at a new alignment where you can avoid sensitive habitats, that's all the better. Where you have impaired water bodies, or where you have designated hazardous material routes, you may have additional requirements beyond level 1, 2, and 3. And then do your planning for these for the stormwater quality and quantity controls as early as you can in the process, so that you can identify your right-of-way requirements to be able to cite those. We are in the process of developing material and posting it. We're just wrapping up this second TriSWM project, the update project. We have a revised ISWM criteria page. We have a new TriSWM guide page, a brochure, and then this workshop is part of our outreach. We'll be sending out additional information with links to certainly these resources, as well as like the Texas Surface Water Quality Standards and others for your information, so you'll have ready access to that information. We also see Brian discreetly in the back videoing. We'll make the video and the corresponding slides available on our ISWM website. We'll send links to where you can find that. So if you have, if you want to go back and refresh, see something that you might have missed for this during this live training, or if you want to send your colleagues to the information, it basically looks like a webinar. It has the presenter and the slides, as well as the slides themselves in PDF format. So we'll be making all that information available. With that, I'll turn it over to Chris to talk about complete streets.
So you've heard the term complete streets. You hear that term quite a bit. It has pretty broad meaning. What I wanted to kind of focus on is some of the tools out there. COG's put together a roadmap for sustainable public right-of-ways. Really the intent of that is to be a reference for municipalities and private developers throughout the planning and design phase to have a set of collection of tools, collection of references you can use as you're developing a complete streets project. These references include, there's actually 10 principles that are identified in that roadmap. The first two are pretty overarching, and actually if you're familiar with the Envision rating system, which we have a few slides on that as well, there's some similarities there. But the first one is Basically, a sustainable project to meet the needs of the present without compromising the ability of future generations to meet their own needs. So that's a pretty overarching type of principle. Next one's very similar, and this one also you'll see in the Envision rating system. It's what they refer to as the triple bottom line. So creating a environmentally friendly, economically feasible, and socially acceptable right-of-way. So as you're developing your complete streets project to involve all three of those aspects in that design and to ultimately create a sustainable project. So other principles, these are probably very familiar to you because many of these are similar to what we're doing today in design. Of course, we're always trying to minimize maintenance costs. Some of these practices, although they're sustainable, they have a maintenance benefit as well. Regulatory compliance is a key element, but promote economic development. That's one that we encounter a lot. Like we actually had the opportunity to work on several urban villages in Fort Worth and working with developers on how to make that block unique. So not only sustainable, but unique to the needs of that community, which involves a lot of public involvement and to kind of promote that economic development. And of course, safety is always a key element. Usually when we're talking about complete streets, we're talking about involving more pedestrians, more bicycles. So looking at these other elements, like reverse angle parking, those kind of elements that provide additional safety as well as meeting the needs of the area. So I mentioned the stakeholder involvement. We all do public meetings in our projects, but trying to take that one notch higher. Having going to like community block parties or those kind of things to understand what that community is looking for. In addition to the typical milestone public meeting, we're trying to kind of have an ongoing process. And if you've looked into the Envision rating system, there's a lot of credits associated with doing that type of approach versus having just a 60% public meeting that's involved throughout the entire process. Of course, when you hear about complete streets, you're always going to hear about making it more pedestrian and bike friendly, and that's a key goal in addition to the sustainable element of it. Improving air quality, of course, that's an important part of what we're doing in our whole region. Water quality is one of those that we're really focused on today. And in fact, Leslie has a great deal of detail around some of the applications you can do to improve water quality for streets. And that's in our next section of the presentation. But really, water quality and sustainable roadways, they're really kind of hand in hand because as Trey mentioned, with the amount of lane miles in the state, and we continue to build more, it's a lot of impervious areas. So looking for opportunities to, as we're developing these infrastructure projects, minimize that impact. And that's where water quality really comes into play. So some of these applications, of course, trying to reduce those pollutants as, Trey and Jeff presented in the previous slides, ultimately trying to reduce the number of vehicles, look for opportunities for more multimodal. I think that's more something that evolves over time. But the second bullet item here is reducing the impervious cover. That's something we can do immediately. So looking at opportunities to maybe narrow the lanes or expand the green areas in the parkways and the medians, different areas throughout your project. You can make an immediate impact on looking at those kind of low-hanging fruit elements of a project. What that involves is more of these best management practices, instituting rain gardens, vegetated swells like you may see in more of a rural roadway, bioretention. That was mentioned several times as more of a engineered way to improve that quality before you release it downstream. And that's what a lot of Leslie's examples are going to kind of go into detail about designing the bioretention. So resources, if you get an opportunity to look at the roadmap for sustainable right-of-ways, what you'll find is a number of these resources. It's a great guide for all aspects of your project, starting from the planning phase throughout the design. Many of these, like the NATCO Urban Design Guide, of course the AASHTO documents, National Complete Streets Coalition. All those references are in that guide and provide you a great deal of detail that you can go to as you're developing your project. The rating system, the vision rating system, that's something that's really caught on in the last few years. Is originally started by ACEC, APWA, and ASCE. They came together and formed the Institute for Sustainable Infrastructure. They teamed up with the Zofness program and came up with the Envision rating system. And it's a really good tool to use, even if the municipality or county, whatever that entity, even if they're not planning to submit it for rating, it's a great design process to follow. Going step by step through how you should handle public involvement to just what kind of rating you could achieve with looking at some of these sustainable practices. We found it to be very beneficial as a design process. There's actually 60 credits. It's very much like the LEED system, and you can get different rating from bronze to platinum. But it's a great tool to go through as you're planning your project and working through what type of credits do you think you can achieve on your specific project.